back to the channel. Today we shall start on one of the processes that we go through as we are developing project prototypes. We shall go through the development of a 12-volt DC supply, a simple one. The first step is to do simulation, and I use Prometheus 8, so let's load it up here. Now at the start screen, you go to File, New Project, give it a name, which is the 12-volt DC power supply. You don't need to worry about anything else, just continue clicking next until finish. Now here, you go to the schematic capture. Now, this is the environment where we draw our circuit diagram. So now let's start getting the components. You come here to pick components from the library. Let's start with V sine or a sine wave AC voltage source. Yes, we place it there by double clicking. Next we shall have a transformer. It will be a simple transformer, so we double click. We shall have a switch. I think a simple one will do, like that one. We shall have a bridge rectifier. Then we shall have a capacitor. We have animated and what, but I think we should go with a simple one. This should work. Then next we shall have 7812 regulator IC. Let's take this one. Since our bridge is 1 amp, or it's going to be 1 amp, basing on the components that you're going to be using. You can get these circuit diagrams. There are many of them all over the internet. I got the simplest one to carry out this demonstration. I'll be showing you, as we shall go on, you'll see how the circuit diagram looks like. So let's move on. We need the resistor. Yes, we need also a LED. Let's go with the green one. There are multiple of them. Let's take this one. I think that's all. You can click OK. Now let's start by putting our voltage source. Click on it and click where in the space, wherever you want to place it. We shall have the transformer. Then from the transformer, but between the alternator or the voltage source and the transformer, we need a switch. So let's get the switch. We shall have a switch there. Then after there, we shall have the bridge rectifier to convert the AC to DC. This is the voltage source, which will probably be 240 volts. Here in Uganda, that's what we use. Then we shall have a transformer that will step down that power from 240 to 12 volt AC. Then this bridge rectifier, we change it to DC. Then we shall have a capacitor here. Then another capacitor. Then we shall have the 7812 regulator IC. Then we shall have another capacitor after it, connected in parallel to the bridge rectifier. All of these capacitors are connected in parallel to the bridge rectifier. Then now we shall have a resistor. This one, let's rotate it 180 degrees. Yes, set it anti-clockwise. Then we shall have a LED. Then here at the end we shall have what will indicate us the voltage that we're getting out of our circuit. So we shall place a terminal. Okay, before we go that, this is the terminal, which is the ground. We need to ground our circuit. That's important. Then now, okay, let's go to placing instruments. We have virtual instruments here. We need the DC voltmeter, so we shall place it somewhere here. Now let's try to put the right values for this component. Some of them don't have the right values. Let's start with the voltage supply. Double click. We can change the amplitude to be 240 volts. Frequency 50 Hz. For Uganda here we use 50 Hz. Then the part value, we can say AC supply, then click OK. Then the transformer, the coupling factor is what we shall be changing, because right now here is meaning what I'm getting at the primary rather is what I get at the secondary, which is not what we want. That's what 1.0 means. But okay, let's start by making it 0.0 say 85. We shall keep adjusting it until we get the right voltage output. So let's click on OK. Okay, we can also name this as transformer. Let's call it transformer. Then come to the bridge rectifier. This is the part value, 1 amp bridge rectifier. Then let's come to the capacitor C1. C1 should be 470 microfarads. 470 microfarads. Capacitor 2 should be 0.1 microfarads, the same as this one here. This should be 0.1 microfarads. This resistor should be 4.7K, 4.7K kilo ohms. The rest I think are okay. Yeah, the rest are okay. So we are left with making the connections. Let's start right away. So you left click. After that, red dot comes. Red dot comes to the next, goes to the next component. You left click again. That's how you make the connections. Let's continue making. Okay, now let's do the simulation. Let's run the simulation. We come here at this play looking like button to run the simulation. Click on it. Now you can see our circuit is active. We come and switch on the transformer, which will power up the whole circuit. As you can see, we have 12 volts at our virtual instrument, meaning when you have this circuit tested and also put into practice, or mounted as a project, it should give you 12 volts. This simulation gives you an assurance that your circuit has 99% chances of working. The 1%, those are faults that can come in, faulty components, broken wires, and many other losses that come in that will make your circuit not to produce the 12 volts net. The 12 volts net, like you can see this one is doing. Yours in practice may give you a slightly lesser voltage or a slightly higher voltage. That is still okay. But this shows you that you are assured that your circuit will work. This is step 1 and it has been simulation. We shall have step 2 and step 3 in the next videos. Keep on the channel, keep on subscribing. Also tell a friend, tell friends, tell family to keep on subscribing to this channel. More videos are coming. Thank you so much for watching, and also click on the notification button so that whenever I upload a video, you'll be the first to know. Thank you very much. God bless.